Hi, this is Alex from devstories.eu. Docker Masterclass, Episode 9 of 18. By default, a running container is completely sealed off from the outside world. It sits in a private bubble, and if you want the internet to reach it, you have to intentionally punch holes through that isolation. Managing those holes and the connections between containers is the job of container networking. When a container starts, Docker assigns it an internal IP address. The container can usually reach out to the internet to download updates or make network calls, but nothing outside the host machine can reach in. To accept incoming traffic, you use port publishing. Publishing takes a port on your physical host machine and binds it directly to a port inside the container. If you have a web server container listening internally on port 80, you can publish it to port 8080 on your host. When a user sends a request to your host machine at port 8080, Docker intercepts it and forwards it straight through the firewall to the container on port 80. You configure this mapping at startup using the publish flag. Without that flag, the container remains inaccessible to the outside network. That covers external traffic. Now, the second piece of this is internal communication. Applications rarely run as a single isolated process. You usually have multiple containers that need to share data. By default, Docker attaches every new container to a built-in network called the default bridge. A bridge is a software-based network switch running on your host machine. It connects containers so they can exchange packets while isolating them from external networks. Here is the key insight. The default bridge allows containers to communicate using their internal IP addresses, but container IP addresses change every time a container restarts or updates. Hard coding an IP address in your application configuration will break your system almost immediately. To solve this, you create a user-defined bridge network. When you attach multiple containers to a custom user-defined bridge, Docker provides automatic internal DNS resolution. This means containers can find each other using their exact container names. Consider a scenario where you have a back-end application container and a database container. You create a single custom bridge network and attach both containers to it. Inside your back-end application code, you do not write a database connection string using a fragile IP address. You simply use the database container's name as the host address. Docker intercepts the DNS query, finds the database container on that specific bridge, and routes the traffic to the correct internal IP address dynamically. This design gives you total control over application security. The backend and the database can talk to each other freely across the custom bridge, but no external traffic can reach the database. To run your application securely, you leave the database hidden on the private internal bridge with no ports published. Then you publish only the backend container's port to your host machine. External users hit the public backend port, and the backend securely queries the database over the private bridge. The architecture of your application dictates your network topology. Use published ports to invite external users in, and custom user-defined bridges to let your internal containers talk to each other securely by name. That is all for this one. Thanks for listening and keep building.